All right, I hope page 1 went pretty smoothly. That seems to be the easiest page. Now we're moving on to page 2. So again, number 9 and 10 are pretty straightforward. I'm still looking at using right triangle trig, which is the SOHCAHTOA part that everyone loves so much. And that's simply because I still have right triangles. Okay, so no law of sines, no law of cosines quite yet. So for this first one, I go to the angle, and again, it helps to label your sides. So this is opposite. And this is the adjacent. So the trig ratio I'm going to use is tangent. Okay, so I'm going to set up tan of my angle is equal to the opposite side over the adjacent side. And again, since I know the angle, I'm going to cross multiply. I get y times the tan of 32 equals 17. So then to get rid of that tan of 32, it's just a number, so I'm going to divide it. So in the end, I get y equals, grab my calculator, 17 divided by tan of 32. Uh-oh. And I get 27.2. Okay, so y equals 2, and we're in centimeters. So 27.2 centimeters is what y is approximately equal to. And let's look at number 10. We're going to do the same method. Identify your sides. Well, the opposite doesn't help me. This is the hypotenuse because it's across from the 90 degree. So what's left over must be my adjacent. I know the adjacent and the hypotenuse, so I'm using cosine. So I have cosine of w equals 17 over 23. And here's one of those cases where I'm trying to solve for this w. To undo cosine, I need to inverse. So w is going to equal cosine inverse of 17 over 23. Cross multiplying would not help me because I just get 23 times cosine of w equals 17. And I'm going to end up dividing that 23 over to be able to inverse. So cross multiplying does not help me. Whenever you need to solve for an angle, you should be thinking I need to use the inverse. So you just grab your calculator. Second cosine of 17 divided 23. Oops, if I could type in my calculator. And I get 42.3 degrees. So that angle is 42.3 degrees. All right. Now we're getting into problems that are no longer right triangles. This is when I should be using law of sines or law of cosines. So I'll look at this first one. And remember, to use cosines, law of cosines, we need to have side, 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 or side, angle, side. So that's the best way to check. Notice here I have a side, an angle, and I don't have that side, so that doesn't work. I have a side, an angle, and still doesn't work. And I don't have all three sides, so for this first one, I'm not going to be using law of cosines. I'm actually going to be using law of sines. And the reason for that is I have an angle on its opposite side. And I know this angle, and I'm trying to find its opposite side. So law of sines look like this. And really what it's saying is sine of an angle over its opposite side, so in this case the opposite side is 25, equals sine of another angle, so we have 53, over its opposite side, which is w. And now we have a proportion that we can cross multiply and solve with. So when I cross multiply, I get w times the sine of 76 equals 25 times the sine of 53. That's just going to be a number, and the sine of 76 is a number. So I'm going to divide both sides by that. Now to w equals this junk, well, I'm just going to grab my calculator and type that in. So I get 25 times sine of 53. And that is 19.96. Then I need to divide that by sine of 76. And I get 20.58. So w equals 20.58. And let's go back up to our picture. Does it make sense that this side is slightly smaller than 25? Well, the angle is smaller, so yes, it makes sense that it's smaller than 25. All right, let's look over here at the next example now. Number 12. Now again, remember cosines, law of cosines. We're looking for side, angle, side, or side, side, side. I know a side, an angle, and a side, and I'm trying to find that one. So this one will be law of cosines because of side, angle, side. And so when I set that up, you have that big long formula. It looks like this: c squared equals a squared plus b squared minus 2ab cosine of c. Well, the only thing you really need to pay attention to is what's your c. So our angle c is 75. Our side c is always the one across from it. So this is nice because I get x squared as my side I'm trying to find. Equals, it doesn't matter whether you call 6.5a or 10.1a. So I get 6.5 squared plus 10.1 squared minus 2 times 6.5 times 10.1 times the cosine. I know the angle is 75. All right, so I'm going to go over to my calculator. I'm just going to type that all in. 6.5 squared plus 10.1 squared minus, let's do all that other stuff next, 2 times 6.5 times 10.1 times cosine of 75. Close my parentheses off. I get x squared equals 110.28. And then I square root it at the very end. I get x equals 10.5. Oops, ignore that second one. I hit it twice. 10.5, and we're in centimeters. So then go back up here. Does it seem reasonable that this side equals 10.5? And yes, I think it seems reasonable because my other sides are near that. It's not massive or way too small. Okay, so let's look at these next couple. I want you to figure out if you can find whether or not you're using sines or cosines. One of them you're using law of sines, the other one you're using law of cosines. So this first one here, again, I look for side, 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 or side, angle, side for cosines. Well, I don't know any sides and angles between, and I don't know all three sides. So I'm going to be using law of sines. And I have an angle and its opposite side, so I'm going to have sine of 50 over 29 equals sine of, I'm trying to find this angle, so we'll just call that sine of A. You don't need to call it X, we'll just call it A since that's the angle we're trying to find, over 37. Okay, so again, this becomes a proportion. I can cross multiply. 37 times the sine of 50 equals 29 times the sine of A. Now my ultimate goal is to get this alone because when I'm solving for an angle at the end, I know I need to inverse. So this side is just a number. 37 times the sine of 50. Okay, I get 28.34. Now to get the sine of A alone, I need to divide by 29. So I'm going to go back to my calculator and just hit divide 29. I get like 977, excuse me, 4. And now once I have sine of A alone to solve for an angle, remember I just need to inverse. So in the end, I get A equals, let's go over here. And I'm just going to take the answer that it already gave. Oops, not the negative, the answer. And I get 77.79. And that's our degree because we found an angle. So go back up to your picture. Does it make reasonable sense? That's 77.9 degrees. Oops, is it 77.79? Excuse me. All right. All right, so then number 14, I told you one was law of sines, one was law of cosines. Side, side, side must mean law of cosines. Okay, and now I'm trying to find angle B, so I'll mark that with, we'll just call it B. Okay, to find my c squared or my c in the problem, it's always the side opposite. So when I get to that long formula, c squared equals a squared plus b squared minus 2ab cosine of c. Here's what I don't know now, but I do know the side length of c. So that's where that 27 is going to go, 27 squared. And it doesn't matter if I call this one a or this one b, so I'm just going to use those. So there's my equation. Okay. So I'm going to go to my calculator and just start calculating things. So 27 squared is 729. So I'm going to just ignore this. It's my way. So I got 729 equals, and then I'm going to add these two together. But notice I'm not going to automatically type this end part in my calculator because that's attached by multiplication. It's 27 times 34 times cosine of c. So I can't add those together yet. So I have 27 squared plus 34 squared. So I'm going to add those together. I get 1885. And I'm going to multiply all these numbers over here, but I can't add it to that 1885. 2 times 27 times 1836. So this part is attached by multiplication. I can't do anything with it, so I'm going to subtract this over. I think that's what I get. Let's just check. Negative 1156 equals negative 1836 cosine of c. I'm going to divide by negative 836 because it's attached by multiplication. You get 0.6296. All right. So in the end, again, when I get down to solving for an angle, the last step is just to inverse it. Oopsie. Equals c. So I go over here and grab my calculator and I get second cosine. So that's the inverse of my answer. And I get 50.97, so 51 degrees. And let's go back up. Write that as our answer. All right, ooh, we got 2 left on this page. This is a long page. It's just a lot of law of sines, a lot of cosines. All right, so we're going to look at this last one. It's going to do with law of sines, law of cosines, and then that 16 is where we have to find the area. Okay, so number 15, we're looking for side, 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 or side, angle, side for law of sines. I have a side, I don't have the angle, and I have a side, so side, angle, side doesn't work in this case. Yes, I have a figure that looks like side, angle, side, but I need to know that angle in order for it to work, and I also don't know all 3 sides. Okay, so we're going to make sure we have an angle on its opposite side, so that's going to be our first ratio for law of sines, 1 sine of 110 over 18. And then notice I'm trying to find this angle n, but I also don't know its opposite side. So instead of finding angle n, I'm going to call something like this, we'll call this x. I know its x's opposite side, so I'm going to find that one first. So sine of x over 12. And now I have a nice ratio that I can, or proportion that I can solve. So I get 12 times sine of 110 equals 18 times the sine of x. And remember, when I'm solving for an angle, I'm trying to get that alone. So I'm going to go ahead and just write divide by 18, even though I haven't calculated that yet. So I'm left with sine of x equals whatever this junk is. So I'm going to type that in my calculator. 12 times the sine of 110. All right, and then divided by 18. And when you get a decimal like this, you should be thinking, oh, that doesn't really make sense for my angular side, so that must mean I need to do one more step, and that is to inverse it. So I'm going to do sine inverse in my calculator, 0.6265. And that's going to give me my angle. And my angle is 38.7. That's this angle, remember. So go back up and see what this is trying to find. This angle now is 38.7. So in the end, I'm going to take these two and subtract from 180. So 180 minus. And in the end, an n is going to equal 31.3 degrees. So n is 31.3 degrees. Okay. All right, and this very last one is finding the area. Now this one is a little tricky because to find the area, we need to find the height. And it doesn't really work out to draw that height because then it splits the only angle I know in this picture up, and we don't know how it divides that angle. And I also don't know this base down here when I do that, so it's not going to help me. So what I'm going to do is draw my height a different way. I'm going to draw it going this way. You could also draw height going this way. That would work as well. Okay. I'm going to draw it going that way though. Okay. So I have a base here of 40, so I know that part. I need to find this height, right? So looking at this 55-degree angle, the height in that case is the opposite side. And this is the hypotenuse of that little right triangle right there, the blue one. So I'm going to set up sine of 55 equals h over 24. And I can do this because I have a right angle. And put over 1 and cross multiply, so I get 24 times sine of 55 equals h. So the height on this is going to be 24 times sine of 55. 19.66. Well, once I get the height, all I need to do is go back to my area formula. So area equals 1/2 base times height. Well, my area, I got to keep the 1/2. The base I know is 40. And the height I now know is 19.66. So I just need to multiply that out. I get 393.2. If I would have used the exact answer, I think I would just get 393, but that's all right. My area is squared centimeters, so my area is 393.2. Right, that is the finish of the second page. A long page, but a good page.